Hello students. So in last video, we have seen the theoretical concept of linear regression. Okay. So today we will do the practical session on this. Like we will take one data set and we will perform linear regression prediction on that. Okay. So what is our problem statement? So sales in thousands of units is given for a particular product as a function of advertising budget. Okay, in thousands of dollar. Okay, for TV, radio, and newspaper media. Suppose that in our role as data scientists, we are asked to suggest. We want to find a function that given input budget for TV, radio, and predict the output sales. Okay, which media contribute to sales. Also visualize the relationship between the features and the response using scatter plot. So we need to visualize the relationship between features and the response using scatter plot. So data loading and description. The advertising dataset captures sales revenue generated with respect to advertisement spent, SMS, and radio, TV, and newspaper. Okay. Mm. So these are the things. So okay, let me open one file. So im- we we will start by importing pandas. Import pandas with alias pd. Import numpy as np. Import cborn as sns. Import matplotlib dot pyplot as plt. Okay, from sklearn import matrix. Mm, from sklearn import matrix. This we will import for uh, RMSC and R square. Allow plots to appear directly in the notebook. So allow plots to appear directly in the notebook. Okay. Percentage matplotlib inline. Okay. So we will run this all. Now we will import our data set. Okay. Okay. So data equal to pd dot read csv. Then we'll provide the link. Then we are not able to connect this. Okay, so let's see. Import pandas as pd. Data equal to pd dot read csv. Data dot to csv lr dot csv. Okay, let's run this. So guys, here let me change this mm, url. So here we have, okay, this is our target variable, radio, newspaper and sales. Okay, what are features? Target variable, advertising dollar is spent on tv. Okay, for a single product in a given market. Okay, in thousands of dollars. Now we have radio, advertising dollar is spent on uh, radio. Newspaper, advertising dollar is spent on newspaper. Okay, now what is the response? It is sales of a single product in a given market in thousand of budget. Okay, great. Now we will do explanatory data analysis. First we will check the shape of this data. Data dot shape. So it has 200 rows and 4 columns. Okay, now we will check data dot info. So here we can see that there are 4 columns: TV, radio, newspaper, sales. All do no variable have null values. Okay, all have float 64 types. Okay, now we will check data dot describe. Data dot describe. Okay, so here we can see that mm, our mean and median. Okay, so mean is 14 point something and median. Okay, that is 12.90. So they are close to each other. So like our target variable is normally distributed. Now we will see the distribution of our target variable. Okay, so data. So for this what we will do, mm, f comma axis equal to plt dot subplots. Okay, then 2 comma 2 comma fixed size equal to 7 comma 7. Okay, then sns dot dspine. Left equal to true. Okay, now what we will do, sns dot distribution plot. Sns dot distribution plot, and like this we will do, as 4 are there, so we will do 4 times. Okay, now here data dot sales. Okay, and then color, for example we will give blue. Okay, comma ax equal to 0 comma 0. Data dot tv, color equal to red. Ax equal to 0 comma 1. data dot radio color equal to green, ax equal to 1 comma 0. Now data dot newspaper color will be magenta and ax equal to 1 comma 1. Okay, so let's run. So sns dot we also need to do one thing, import warnings. Okay, warnings dot ignore warnings dot filter warnings, then ignore. So now this here we can see that sales seem to be normally distributed. Okay, spending on newspaper advertisement seems to be uh, right skewed. Okay, most of the spend on newspaper is fairly low, where the spend on radio and TV seems to be uniform distribution. Okay, spend on TV are comparatively higher than spend on radio and newspaper. So spend on TV is comparatively higher. Okay, so now we try to find, is there a relationship between sales and spend various advertising channels. Okay, so we will try to find, is there any relationship between sales jg1 equal to sns dot joint plot paper comma sales comma data equal to data comma kind equal to rag plot. Now jg2 equal to sns dot joint plot radio and sales data comma kind equal to rag. jg3 is equal to sns dot joint plot, and then we have TV comma sales comma data equal to data comma kind equal to rag. Okay, so 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 guys, here we can see that sales and newspaper is very less correlated. Okay, sales and newspaper between radio and sales, it is more than uh, so now, and in the last we can see TV and sales, it is highly correlated. Okay, so these are the things we can see. Okay, now we will visualize pairwise correlation. So SNS dot pair plot, then data comma size equal to 2 comma aspect equal to 1.5. Okay, so here also we can see TV uh, and sales are highly correlated. Okay, and TV and this newspaper is less correlated, and this TV and radio is very less correlated. Okay, so these are the things which we can see from here also. Now we will do pair plot in different manner, like SNS dot pair plot data comma x variables is equal to TB comma radio comma newspaper y will be sales, size will be 5, aspect will be 1, and kind will be reg. Size will be 5 comma kind will be reg. Okay, so mm, so we can see that there is a strong relationship between TV ads and sales. We radio and no relation between newspaper and sales. Okay, so this is the thing. Okay, so now we will calculating and plotting the heat map correlation. Okay, so what we will do, data dot correlation. Okay, so for correlation, uh, our correlation should be less than zero point 0.8. So here we can see that our correlation is less than zero point 0.8 everywhere. Okay, sales and TV have highest correlation, that is 0.78. Okay, TV and radio, TV, newspaper, and TV and sales. Okay, so we will plot heat map SNS dot heat map. Okay, data dot core comma not equal to true. So we can see this also. Okay, now we can see that so the autocorrelation of variables, it is always 1. Okay, so you can observe that the correlation time is highest, that is 0.78. Okay, can vary from -1 to 1, closer to strong positive and negative. Okay, so now this is the introduction of linear regression, which I have already explained you in theory, so no need to explain it again. You can if you want, you can read it here. Okay, now another step is preparing x and y using pandas. Okay, so preparing x and y using pandas. Okay, so standardization. Okay, standardize features by removing the mean and scaling to unit standard deviation. Okay, so we are standardizing. Okay, so now feature columns will be TV, radio, and newspaper. Okay, so feature columns and then x equal to data, feature columns, y equal to data cells, columns equal to TV, comma radio, comma newspaper, x equal to data, feature columns, y equal to data dot sales. Okay, so this is the thing. Okay, so now we will do external. So we have divided x and y from sklearn dot model selection import train test split, then x train comma x test, y train y test, train test split x comma y. Okay, so we have also we need to define that sample size what we need to keep. Okay, so test size equal to 0.2. So like this we will do. Okay, so x train dot shape okay, y test dot shape 40. Okay, so this is the thing. Now we will import the class, then we will create the object dot fit and object dot transform. But before this we need to do min max scaling also. Okay, so from sklearn dot preprocessing import min max scaling, min max scaler. Okay, uh, now we will define CALER scalar equal to min max scalar, then scalar dot fit x train. Okay, then x train scale equal to scalar dot transform x train. Okay, so let's do that. So now we can see that x train as will be like this minimum, so it will be converted as per min max scalar. Okay, now test data mimics the data set which will come tomorrow. So we need to do this separately. Okay, for this, so x test as equal to scalar dot transform x test. Okay, so this will transform x test. So we will again give the name of those columns. Okay, so x train as equal to pd dot data frame, data equal to x train as comma columns equal to features column. Okay, so x train as will come like this. Okay, okay, so this is the thing. Now x test as also we will do same thing. Pd dot data frame, now data equal to x test as comma columns equal to mm, features columns. Okay, so as test as will come out like this. Total will be 40 values. Okay, it will be like this. Okay, x test s. Now we can check all things, this things we have done. Now it's time. What will we do? From sklearn dot linear model import linear regression. Okay, then from sklearn import matrix. Okay, now uh, reg equal to linear regression. Linear reg dot fit x train s comma y train. Okay, y predicted test. Test equal to linear reg dot transform dot predict x test. X test s. Okay, so RMSC test will become np dot square root of matrix dot mean squared error, and in this y train y test comma y predicted test. Y predicted train equal to linear reg dot predict x train s then RMSC predict equal to np dot square root, then matrix dot mean squared error, and then y predicted train y train. Okay, so let's run this. So what we have done here, from sklearn.linear model import linear regression, from sklearn import matrix the linear reg we have created object, then linear reg dot fit x train s comma y. Okay, then y predicted test will be x train s, then we will calculate error, and then y predicted train will be linear x train x. Okay, so this will come. Okay, so what will be the value of RMSC test? It will be 1.48. Okay, and RMSC predicted will be 1.71. Okay, also y predicted test will be the array like this. Okay, and y predicted train will be the array like this. So this is the thing. So now we will interpret model coefficients. Okay, so now we will print model coefficient intercept will come to linear reg dot intercept. Okay, print coefficients. Linear reg dot coefficients. Okay, so coefficient will be these 13, 8 and 0.550. Okay, now we can calculate other things also. For example, sum square residual. Okay, sum square total. Y actual means y test minus test square sum square total and r squared value also we can calculate. So guys, if we want to calculate some square residual, okay, then sum of y test minus y predicted test square, so it will come as 88. Okay, now r squared will come as 1 minus float of sum square residual divided by the sum square total. Okay, so sum square total will be sum of y test minus np dot mean y test square. So print it will come as 0.91. Okay, so you can see that it will come as 0.91 and here this value RMSC come as 1.48 1.71 something. Okay, it's hard to remember the order of the features names. Okay, it is very hard that we will remember the sequence of feature name. So we are zipping the features to pair the feature name with the coefficient. So we are zipping the features to pair the features name with the coefficient. So what we will do, features columns dot insert, then index comma object. Okay, 0 comma intercept, as we have calculated here na, intercept. Okay, now coefficient equal to linear reg dot coefficient comma to list. Features column will be dot insert 0 comma intercept coefficient linear reg dot coefficient dot to list. Now coefficient dot insert 0 linear dot intercept. So equation 1 equal to zip feature columns comma coefficient for C1 comma C2. In equation 1 print C1 comma C2. So intercept will come out as 2.89. For TV it will come, for radio it will come, and for newspaper it will come. Okay, so like this we can do feature column dot insert. So at 0 it will come intercept, then coefficient to list, then coefficient dot insert, uh, 0 comma uh, linear rect dot insert intercept. Okay, so it has zip feature columns comma coefficients. So like this we can do. Now what we can do, feature selection. So we using the model for prediction. So I predict. So all this we have done. Okay guys, so thank you. I hope you get the idea of this.